Everyone. Thank you to the first session of today's TechShares event. The TechShares event for today is titled Top Big Data Opportunities for Telecom Companies. And our TechShares events, they're a forum for technology leaders to connect with business leaders to help their organizations create better software solutions that utilize open source software more effectively. So originally on the schedule was supposed to be a conversation with Lalita Krishnamurthy this morning. Unfortunately, she was not able to make it. And so instead we have Travis Oliphant in to discuss the same topic, best practices for successful big data implementations. Travis is, oh my goodness. Travis is the leader, a well-established leader in the Python data science community. He has a wealth of experience developing applications and improving the software for a wide variety of companies, Fortune 500 and beyond. Travis led the creation of cornerstone open source projects, including NumPy, SciPy, Numba, Anaconda, and organizations such as NumFOCUS and PyData. And he founded the companies Anaconda and Quansight before founding OpenTeams most recently. He holds a doctorate in biomedical engineering from the Mayo Clinic and a Master of Science in Mathematics and Electrical Engineering from Brigham Young University. Travis, welcome. Thank you very much for participating in the event today.
Thanks, Brian. Appreciate that.
Of course. So again, the first topic that we have is best practices for successful big data implementations. So let's start there. What are some of the most essential big data best practices when you're designing things like IT infrastructure for data analytics?
Yeah, great question. It's an important question for a lot of people these days because the technologies are changing all the time, and have been changing for the past 10 years. This is where you're getting second fiddle. You're getting Lalita was specifically chosen for these questions. So I'll do my best and definitely have my own experiences I'm eager to share. But definitely we're missing Lalita this morning. But I have had my own experiences with a lot of companies trying to handle and get ahead of this big data. In fact, Anaconda was founded around the big data wave of the 2012, 2011, 2012 timeframe when big data was all the rage. And we were noticing that, okay, great, there's a lot of emphasis on big data, especially scalable big data, but yet we are still finding a lot of our customers were using Python and really most of the time just needed a bigger machine and a bigger hard drive, right? They didn't necessarily need scalable computing. I think that's one of the key things to keep in mind is that, there's always somebody trying to sell you something. And so don't let the person just trying to sell you something frame the conversation. You ought to be able to frame the conversation according to your actual requirements. What are your actual requirements? What are your actual needs? Do you need 1,000 machines? Do you need a massive store? A terabyte of data is not big data. These days, 1,000 terabytes starts to be big data. An exabyte, definitely big data. So you have to kind of make sure you're not, falling in. We would find people that go, oh, I have big data, and they're really talking about 10 gigabytes or 100 gigabytes. Mm-hmm. That's not, if you can find a USB drive to stick your data on, it's not big data, right? So, and that's the case. There are large data sets. So I think one best practice is to don't be sold. Keep the focus on what your actual needs are, and recognize there's a lot of voices out there that are just trying to sell a product. One of the things I love about the OpenTeams model is we're actually there to help make people aware of the open source solutions that exist. And now everybody knows that open source is everywhere and is dominating the substrate of technology. And a lot of big data solutions are in fact open source, but understanding that open source, understanding where it fits is a big deal. So, keep the focus on your business. Don't get carried away by some marketing voice. I think is a really critical point. I think making sure you have the right leadership around the team you're asking to do the project. You're not going to solve a problem by just hiring a bunch of people. Just going and saying, hey, I have this big data problem. Cool. Let me go buy a bunch of machines and put a bunch of people on it and hope that something emerges from that is not a good idea. You're going to need to have kind of somebody who's accountable and taking charge of the business needs, and then probably several layers of that as you go, and then finding the right people for the job. Don't try to hire all the people in house. I think that's a mistake a lot of people make because they think that their best option is to go hire the whole team. Now you do need to hire key people, but you also need to recognize there's a lot of smart people outside your organization that can help you that aren't in your organization, and that's okay. as long as they're organized well and connected to your business goals, your business needs. I think making sure you can look into your data. So there's some kind of data visualization. Make sure that you're aware of what's there, what you're seeing. You can regularly look at it. So what's your data visualization strategy? What's your data visualization story? And more generally, what's your dashboarding mechanism? Or what's your way you're going to get the information from your data to people? So yeah, data is there, but data is just, I would often show a picture of a big data lake house, it's sort of in the woods, nobody can see. Like a lot of times people have big data, but it's just sitting there and you can't make use of it. Making use of it means it's got to go through the minds of your people. To go through the minds of your people, it's got to, there's visualizations, there's code, there's reports. Things have to be part of your processes to make sure it's real. So I think iteration is critical. Recognize it's not like you're going to have a big monolithic project that gets to end state and then you're done. Actually, it's going to be an iterative process to say, how do I get my company, my organization, the people in the organization to get around that data and to be iterating with it. And so this is where things like Jupyter Notebooks are really popular, because notebooks give you a chance to, it gives you a chance to do lots of exploratory visualizations. Like I think for most people, I recommend using notebooks as a way to get into your data and start with it. Like if people are used to notebooks, they can kind of, I can do a query. And then having your data available through some kind of SQL or Parquet files or there's many languages with solutions that let you put a data frame in front of people. And so get a data frame and start to look through it and then start to analyze it. And then once you figure out what you're going to do, then you can operationalize that and put it into production. So, but notebooks or similar kinds of interfaces give you that iterative approach to understanding your data. I think you have to really take a hard look at am I going to use cloud? Am I going to use, how does cloud and on premises interact for you? Like you're going to make use of cloud in your big data solution. But not only because there's a lot of data in the cloud that you want to connect with and join with, that you're going to want to do that with, but also because it's just more efficient to do large-scale exploratory projects rather than having to buy a bunch of machines. You don't know how much of those machines you're going to need. You'll try to expand a new idea in the cloud. Then when you figure out what you're going to promote, pull it back. That's fine. And you can pull back the piece you want on premises and you'll save some money that way. Anyway, and I think the last point I'll make is just governance and compliance issues. I mean, some areas of big data, healthcare, financial data, there's some compliance issues you have to be aware of and make sure you've got somebody paying attention to. But then also just everybody is concerned about what's the security posture and and which of these data that I have is more sensitive than others. So anyway, that's a rundown. I have a bunch of things to think about.
No, very, very important points all. I mean, definitely the security elements are all evergreen, and it seems to me governance is definitely something that kind of has been lagging from what I've seen in awareness of just how important it is. But it's catching up, and there's tooling and processes that are coming up to meet that need.
Yeah.
So that kind of naturally leads to the sort of the flip side of what are the best practices, what are some of the challenges that organizations run into as they attempt to implement big data-driven solutions that trip them up or end up potentially preventing them from achieving their goals there.
Yeah, it's interesting. I think that is one thing that the past 10 years of data-driven focus, a lot of marketing focus around big data, has helped improve some of the cultures. Anecdotes from yesteryear where there would be people who owned the data. Like if you wanted access to a particular data table or data information, there's that one person in accounting or one person in HR that you had to kind of go, and they were the gateway. And it was not like the process was no real process, but I've heard stories of, and I've talked to people who they basically went, on Tuesdays, I'll take a candy bar to this person, and then they'll send me a little information. And so it's like, okay, so your process is bribe and release or something. And that's kind of the reality is that's real. There's like these a lot of data in organizations has been siloed, has been owned, has been controlled by certain gatekeepers. And one of the things I think it has been helpful to break down those barriers. Even though I've not been a big fan of some of the big data technologies of the past years, I think they're much better now. I think one thing that has always helped is to break down these silos of data ownership and recognize, hey, we need to put security protocols and access controls around data that not everybody should have, but we do need to be able to share and understand that data with kind of more consistency and more regular practice, and not make it this, bribe and release approach to data. So I think that's one of the challenges, is just the fact that there are different organizational elements. There's a principle. Conway's law says that software is it's a law, really. It's an observation that most software it evolves to reflect the organization that created it, and data policies kind of are the same way. Data policies evolve to reflect the organization that installed them, and so you'll have data siloed, and usually that's done for security purposes. A lot of times there's justification for it. So I think that's one of the challenges. How do you? Okay, we have these necessary divide and conquer approaches. We know that we can't have every decision running through a big committee. We got to have people have independence of management. Then how do I have the data that they produce come someplace where it can be shared? So I think that's one of the natural challenges. Another one I've observed that is not often talked about is the fact that people, if you are trying to get information, you have a purpose for that information. I have data, and I have a purpose to analyze that data. So you care about certain attributes. You're going to want to, let's say you're renting houses, and you want to know who the renter's information about the renter, and there's also information about the property. And now you're selling houses, and you don't really necessarily care a little bit about the renters, but you more care about the attributes of the house. So you want different data in order to analyze what you're trying to produce. The dashboard you're creating needs different data. So you end up with these groups of people that have different needs for the attributes. And so the question becomes, who's going to maintain all the joined attributes? Who's going to maintain them? People care about the attributes they care about. They don't necessarily care about the other attributes. And so really you end up with a system, and sometimes those attributes can be overlapping, but with different framings. So, somebody might, as simple as just spelling. Somebody's in the UK and they have English spelling for the UK spellings, and in the US they have US spellings in the US. Like, those are minor, but it illustrates that whoever is in charge of the data cares about what they care about, and somebody else who wants to use that data may care about it differently. Are you going to push your preferences onto their database? So in practice, what happens is data has a starting point, but then people need to use it differently, and so there's adaptations of data. And so once you have an adaptation of data, then who's going to maintain that adaptation? Are you forcing the original creator of the data to maintain your preferences? Like, a lot of people imply that. They haven't realized, oh, wait, yeah, I've got to be in charge of those adaptations and then own that. I can't just assume that some other department's going to give me information that I care about, but they don't. Right. So I think a lot of organizations actually struggle fundamentally with that reality. It's that fundamental, these business issues are a little different. And so then and it translates to the schema this person wants is different than the schema I want. And so I do have different data, even though they share common elements. So, where that can go really well is if people, so that's a fundamental business challenge, fundamental people challenge. So it does lead to, okay, well, do we find a common substrate that can be, combined, that can be shared? But of course, shared coalitions can often lead to those challenges too. So anyway, those are some of the challenges. I think some are people, they're natural organizational human challenges, and then a few are technology. The technology ones are overcomable, right? Most of the challenges, I think, are information and thinking, and then also people's framing, and the fact that there's a lot of people out there pushing an agenda. Or I don't mean to say that pejoratively. I just mean people have a thing they're trying to produce.
Yes,
and that thing they're trying to promote may not be the thing you care about.
So, one of those challenges relating to what you just said is, I think it's kind of captured in the emergence of data engineering as a relatively new discipline, trying to deal with those different needs and making sure that everyone who needs data a certain way can get it in a clean fashion.
It's an excellent point. The data engineering then becomes kind of it's about data in motion, data where it's moving from one place to another and recognizing that's a thing, and then it needs to be managed and maintained. Very, very good.
Yeah.
Yep.
So, you also mentioned security. That's again was touched on in the first question.
Do
you have any thoughts about specific elements that an implementer of a big data project need to think about in terms of their data security? Yeah,
security becomes is definitely one of those challenges because of different. There's sort of the natural approach, or let's see, the ultimate approach to security is we just don't share any of the data. Like, like the best way to lock it down is to lock it down and nobody sees it. So there's sort of this correlation between, well, I want to be secure, but I also need to use the data. So what's that trade-off? And you end up with different philosophies in different organizations about how to handle that natural tension. Some people will go, well, and my view is that it actually depends on the story and the context. Like, what's the risk associated with security breach? And the higher the risk, the more stringent you probably become, the more careful you're going to become. But there's some things where the security risk is low, or the consequence of a security breach are also relatively low. And so, we don't need to lock that down quite as hard. So understanding the context of a security is a challenge, because you often end up with, well, let's get the security person in. And security people in nature, they're kind of like lawyers. Lawyers by nature are looking for reasons why things may go wrong. That's what they're paid to do, is look for what's going to go wrong. Yes. And so in a lot of ways, so I love lawyers. They're awesome. But lawyers, as a business owner, lawyers work for me, right? And they provide me information about risk assessment and things that can go wrong. And then I have to make a choice as to how I'm going to deal with it. Lawyers, so a lot of times in security, it's the same way. Security professionals, security conscious individuals somebody has to make a decision, and that or some group has to make a decision. That group is ultimately accountable for the decision, not the security professional they hired to help. So I think a lot of times that's hard, because being in charge means you're being accountable means you're accountable, and it's risky to be accountable. And a lot of times people try to push accountability somewhere else and save their own skin. I think that's a fundamental human trait. I think a lot of businesses end up essentially with little eddy currents of behavior, organizational challenges that rooted in that fundamental trait of humans to want to avoid, just avoid blame and avoid decision making, kind of push off decision making to somebody else.
Indeed, yeah.
So security has to be taken care of. It depends on the context, and you've got to make sure you're getting the right people and the right advice, and then make sure you're recognizing advice as advice if you're a decision maker, and not just sort of handing over accountability to somebody that ultimately doesn't have the accountability and trying to pretend they do.
I guess recognizing that the security situation evolves over time.
I think it does. Yeah, there's some situations. Again, it depends on your situation. There's certain areas of data security where there's a legal framework that you have to recognize that it's more than just your business decision. There's a legal consequences of having breach. Yeah. And then there's business consequences of having breach in other cases, which also do have legal elements to it. But I'm sort of there's sort of criminality or civil lawsuits on one hand. On the other hand, it may just be civil. It may be business
effect. Impact.
Yeah, or you lose business. That's the primary one. You have a breach and you lose business.
Yeah, it does not look good when that happens.
So, correct.
So changing gears a little bit, more again to the data technology side. When a company or an entity is trying to, so again, to implement a unified big data project, a lot of the time they can have data sources, a wide variety of data sources distributed over a wide variety of systems that all need to be pulled together into a unified big data project. And so what are some of the challenges associated there? What are kind of tooling best practices or procedural best practices to start trying to pull all those threads together into a unified whole?
Yeah, it's a great question. That really gets back to the story I was describing before of different departments have different schema needs. And so kind of a universal schema will never work. It's the same problem of saying, hey, we're going to have this universal object that all use cases of this are going to love. Sometimes you can. I mean, if you can find it, awesome. If you can find that schema or that description of data that many, many people share, a common goal, that's fantastic. Then double down on it. Grow it, create it, because you have multiple people who are going to consume it, and you can really make a solid solution. But that data integration problem, there's a part of it that's fundamental to the domains. So recognizing what part of your data integration problem is fundamental, and recognize what part of it is simply proximal, simply technology. Because the technology integration problems can be overcome. The fundamental mental integration problems or the abstraction integration problems of different departments, different schemas of need, you can't overcome that with technology. You can pretend, you can paper over it. Like I think a lot of organizations, they've never acknowledged that fundamental abstraction problem of data integration. And so they think it can be solved just with better technology, but it can't. It actually has to, you can maybe solve it by agreement on a better abstraction, on a subset of abstractions, but that's the hard work. I've seen that, for example, in large commercial banking organizations or investment banks, where they've got many derivatives, and then those derivatives are each being produced by different teams of traders. Those teams of traders have different, and pulling that all together was a tremendous amount of work to create kind of technology substrate that captures the full schemas for everybody. There's some interesting technology that went on that I was able to witness. But the fundamental issue wasn't because they didn't share a common tech. The fundamental issue was they had different ways of thinking about the problem, and then the different schema that resulted from that way of thinking about the problem are different. So I don't know. The audience is full of people, some with technology experience, but everybody understands the notion of here's my table, and here's the columns in the table, and here's the attributes I'm keeping track of. There's a one-to-one mapping between data schemas and object-oriented technology. It's actually really fascinating. These sort of ORM maps expose this. But so you see the same problems in technology development. Hey, I'm trying to get a group of people together to build a framework or a object-oriented structure to help a bunch of people. And that's really easy to do when you have a small group of people who are saying, hey, here's how we're going to think about the problem. And then you take that and try to make it a widespread library. NumPy helped me realize this pretty substantially. Like NumPy is a tensor library, it's an array library in the array, used widely, and it's a common concept that's been around for several decades. Actually, I didn't invent the concept in the array, right? That concept existed in Fortran and elsewhere, but the attributes needed, there's quite a bit of debate about what do you actually need to take hold of with an ND array. Fairly uniform. As we in Quansight Labs produced something called data APIs, go to data-apis.org, and it produced an array standard. That standard was started with NumPy and then kind of formalized in data APIs array standard. And then at the same time, data APIs is also doing a data frame standard. Well, the array standard was a lot easier to get to. The data frame standard is still a work in progress, right? Because fundamentally, data frames, while simple to say, you actually are evoking different things in the minds of a lot of users. So some people, a data frame means I've got to have missing data look like this. Others, I've got to have indexing look like this. So the attributes and behaviors of that object are a little different, and we don't share it. That's an explicit example of this abstraction I've been talking about, this concept I've been talking about of data of different domains, different departments, different organizations may use the same word to describe a data record, but they actually care about different things. And so the effort involved in unifying or integrating with somebody else who has a data source that says the same thing might actually be pretty significant, because they have different titles for anything. It may be simple, like, they just use a different name for that same attribute. Okay, cool. Is it the same attribute? Maybe that same name, it's not just a synonym. It's a small, it's like a little bit of a different framing. And so they have different set of possible values that attribute can take.
Certainly.
So anyway, there's a fundamental thing here that really is about abstraction and how people think about problems and breaking down problems. So it's not solvable by just having, technology. Now, better technology can help expose the issue, help resolve the issue, help us understand the differences between schema, then help us kind of make decisions as an organization about, there's departments in an organization. The organization can make a decision and say, well, how about if this department does this thing and this department does this thing, can we compromise and use a common thing? Yes. Okay, cool. Let's do that. No. Well, then is there a substrate that is in common? And then we adapt. And so we have adapted things that departments use that they can then control and own, but they're all using a common ground that can be co-invested in.
It's a communication problem to start, really.
Communication, and that communication is subtle often. It's often subtle because it has all the same problems of language communication, where I'm saying words and you're hearing something that I didn't quite mean.
It's making a picture in my head that's different than the picture in your head.
Yes, correct. And it turns out data has the same properties. And so so data integration tools, though they exist. There's some really great technology around what I call data catalogs. Right now, that's for the past 4 years, I've been very excited by the data catalog movement, and kind of the fact that, because what data catalogs are doing is exposing schema. Like, rather than worry about data, the data catalog's purpose is to put, here's a name, here's the schema associated with this data, and then descriptions of it, and then kind of where it is. And then make it easy to grab to help you solve your problem. I think that's very, very helpful. Great data catalogs are going to make it easy for you to pull that data into your programming environment of choice, whether it be Julia or Python or R or Excel, right? You're going to be able to, just reference that data by name, as opposed to having to kind of, can we read this data in? Let me see, is it a Parquet file or CSV? It's almost like the data catalog should take care of that for you. And it pulls it in. So you as a programmer or a data scientist, data engineer can just focus on, okay, now what? I need to drop these columns, tweak these ones, clean up these versions. And that's what my code can do. So there's some really good tools like that. There's a lot of other tools out there that are in that space, but that's one of my favorite ones is data catalogs for data integration.
Yeah, lots of new tools in development to try to solve these big problems. So
correct.
We are, as it happens, we are coming up on the end of the time slot. So I think we will wrap the conversation on this topic here. Travis, thank you very much for your time, for stepping in for Lavita. We wish her well, recover quickly, and really appreciate the time. And
absolutely. It's been great to talk with you, Brian. Thank you so much.
Same here. Thank you. So we will pause for a few minutes to reset for the next session, which will be Travis again speaking about, conversing about selecting open source software for your big data product stack. So hold tight. We'll be back in a minute.
Thank you.